Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through a series of differential equation problems which covers some particular topics, right? So, if this is the first time you are visiting this channel, kindly subscribe to support and please stay to the end of the video so that you understand how different problems are being solved under different topics. So, we go straight to the first problem that we have here. This is under systems of equations. So, how to solve a differential equation using systems of equation problem, right? Okay, so is that the problem says convert the following differential equation into a system, solve the system and use this solution to get a solution to the original differential equation. So we have the differential equation here with the initial boundary conditions, and here we are supposed to convert this into a system of linear differential equation, right? So the idea behind systems of differential equation is if I give you any higher order differential equation, being it, let's say, if you have a differential equation y to the power 1, 2, 3, 4, 5, that is a fifth derivative, right? What system seeks to do is you can break this, which is to the power 5, down into a series of what? First order linear differential equation in a matrix form. Then you can solve each first order, I mean, you can solve it independently, right? So you end up solving every higher order with just, I mean, a representation in the first order. So that convert this to the system as well as also solve it appropriately. Don't forget to subscribe if this is the first time you have been on this channel. So solution. Okay, so we have our differential equation already here. So whenever you want to convert it to a system, okay, um, we have to first make some, let me say, I'll say general, for every system of differential equation, which is, I mean, a system of first order differential equation stemming from a higher order, it's given in the form a vector, right, of x prime. So this is the first derivative, a set of first derivatives, which is equal to a certain coefficient matrix multiplying the undifferentiated form of the x, right? So this is actually what we want to achieve. This is what we want to achieve. So this kind of simple equation here, right? Okay. So now, for us to get this form, we always use variables to represent. So right now, the y prime prime, the y prime, and the y that we have, we need to get rid of all of them and make them in terms of x. So we have x1, x2, x3, depending on the number of, or depending on the order of our differential equation. So here we have the order two. So the very first thing you do is you just write x1 is equal to y. So you let x1, right? You let x1 be equal to y. Once you make x1 to be equal to y, then you say that x1 prime is equal to y prime. Okay, this is the first step, prime, right? So wherever I see y prime, I can say that it's what x1 prime. But you see, at this point, okay, looking at the general equation here, let me show you something here. Looking at the general equation, our goal is that on the left hand side, you have a set of all derivatives, but on the right hand side, we should get the undifferentiated form of what our derivatives here. Therefore, we cannot have derivative on both left and right hand side. Therefore, what do I do? I need to simply equate my x1 prime to be equal to what? X2. Okay, I'll get x2. Once you get x2, you come back. Therefore, my x2 is simply equal to what? Y prime. That is one thing which you have here. So if you know that your x2 is equal to your y prime, then if I differentiate my x2 prime, what do I get? I get y prime prime, right? And please take note, we don't need y prime prime. We need to convert y prime prime into a system of undifferentiated or variables. So what do we do? Now, if we try to equate this to x3, meaning that we need to get x3 prime, and that would lead us to y prime prime prime, which is an error. So all the time, once you reach the maximum derivative, you stop. So here you know that you have reached x2 prime is equal to y prime prime. Please stop, don't move again. So once you stop, we need to make sure that y prime prime is not there. We should convert y prime prime in terms of x1 and x2. How would you do that? We go back to the equation. So from the equation, you realize that if I have this equation here, I can make y prime prime the subject. So I'll have 2y prime. This one, everything will go to the right side. So I'll have negative 5y prime 2. Okay. So here I'll replace it here. Therefore, I'll say that this is equal to negative 5y prime over 2 plus 3y over 2. So still we haven't, changed the variables. It's still y and y. So therefore, you say that x2 prime is equal to, wherever I see y prime, remember y prime is equal to what? X2. Wherever I see y, remember y is what? X1. Therefore, you say that our x2 prime is equal to what? Negative 5 over 2 x2 plus 3 over 2 x1. As simple as that. So you can see that my equation here is satisfied. I have a set of derivatives, a certain coefficient multiplying what? The undifferentiated form of my what? My x. And that is what I have here. So we are about to extract our, to express it in. So rightly, as you can see here, I'll simply have my first matrix. I'll have my x1 prime, x2 prime, representing this, okay, should be equal to a certain coefficient. The coefficient is that this is my first equation. So let me use a different color. So this is my first nicely here. Then I'll have my second equation also here nicely here. Okay. Therefore, I'm to represent this as a matrix. So I'll extract their derivatives first, x1 prime, x2 prime, that will be in 1. Then the second one will be the coefficient, that is the a, okay? So when I come to my first equation, realize that I have only x2 present, meaning my x1 is what, 0, right? So 0, 1, nicely. Then when I come to my second equation, my x1 coefficient is what, 3 out of 2. My x2 is what, negative 5 out of what? As simple as that. Then it will multiply what? X1, x2. So we have still extracted it, right? Then we are not done. There is one thing more. Remember that we have our initial conditions also in what? Y's and what? Y prime. We need to get rid of that. So you know y is what? X1. So I can represent my initial condition specially as what? My x1 of 0 is what? Negative 4. And my x, this y prime is what? X2. Okay. X2 of 0 is what? 9. Therefore, we will introduce our initial conditions as part of our equation here. So just observe what so realize that of 0, that is 0. So when I use x with the arrow, I'm just representing the x1 and x2 is equal to negative 4, 9. This one is understandable. This is simply equal to that if I multiply 0, 1, 3 out of 2, negative 5 out of 2 times our x here, right? I should get what? Negative 4, right? Simple as that. So we are trying to create a system of equations which when we solve, we should be able to get the solution for a differential equation. Okay, so how do we solve our differential equation as we have here? Okay, so generally, this is where we are going to go. So you see that our x prime, our x with this bar prime, okay, is equal to I have 0, 1, 3 over 2, 5 over 2, where my x of 0 equal to what? Negative 4, 9. So at this point, we introduce eigenvalues and eigenvectors. For you to solve any second order differential equation using the system equation, remember that your characteristic equation, which in the usual formula you find your R1 and your R2. Now we use the eigen values and eigen. So your R1 that you always find in the R2 now becomes your eigenvalue. So one of your eigenvalues becomes your R1, the other becomes your R2. Then each of these will multiply the eigenvector, their corresponding eigenvector, and that becomes the solution to the differential equation. Okay, so let's see how we can do that. So we come to our matrix here, and remember that for you to find the eigenvalues and eigenvectors, what do? Write your characteristic equation represented as A minus lambda I, right? A minus lambda I, where I is a certain um, identity matrix. Okay, and this is 2 by 2, so obviously. So you just find the determinant of this characteristic, um, let's say equation here, then you put it to 0. So this whole thing becomes our characteristic equation now in terms of matrices. My A is my coefficient minus what? Minus this. This is what you get. 0, 1, 3 out of 2, 5 out of 2. Our what becomes lambda 0, 0, lambda. That not it. So we are going to get negative lambda 1, 3 out of 2, 5 minus what lambda. The determinant of this, and it should give us what 0. All like that. Determinant of this should give us 0. That gives us our characteristic equation. So we simply do what cross multiply, right? I'll have this multiply. I'll have negative 5 lambda, right? Then I'll have plus lambda squared minus 3 out of 2 equal to 0. Okay, so here what do I get? When I try to interchange it, I'm going to have so let's see. Okay, I think I omitted something here. So it was 5 out of 2. I made it 5, right? 5 out of 2. So 5 out of 2 minus lambda, right? Good. So I'm coming here, making. Okay, so here you are going to do what? The simple multiplication, right? So with the simple multiplication, you are going to our get lambda squared minus 5 out of 2 lambda minus 3 out of 2 equal to 0. Okay, so once you have this, you will have to find the values, right? So you find the values. So one easier way is for you to first of all, you know that we can. This one is lambda. So I think I'm making some short glitches here, right? Okay. So simply punch this into the calculator and let's see something. We're getting eigenvalues 1 equal to negative 3, eigenvalue 2 equal to half, right? So once you get your eigenvalues, then you are going to have the corresponding eigenvectors calculated. Okay. So for eigenvalue 1, which is negative 3, what to be the corresponding eigenvector, right? So you come back to your equation here and you realize that you have negative lambda 1, 3 out of 2, 5 over 2 minus lambda, right? Minus lambda. Okay, I think, yeah, so I think I have seen some error here. So when I reach here, it was negative 5 out of 2, right? So negative 5 out of 2. Don't know why I eliminated negative 5 out of 2. So here is negative 5 out of 2. Please take note of that. So I have negative 5 out of 2 here, nicely. Then here too is negative 5 out of 2. So my equation should be corrected here. Prevent inconsistencies in your solution. Okay. So you have this here. Now, since I have changed it, I'm going to have um 5 out of 2 lambda, right? Plus lambda squared minus 3 out of 2 equal to 0, right? Good. So now you can punch this one and getting your, what do you say? You should be getting your first one to be negative 3 and the second one to be equal to half, right? So once you have this done, then when our lambda is equal to negative 3, what's the corresponding vector, right? So we come back to your characteristic equation, then you replace it. Okay. So I'm going to have here to be 3 because this negative 3, this negative lambda. Is that not it? So it becomes positive 3. Then I'll get my 1. I'll get my 3 out of 2. And I have negative 5 out of 2 minus is 3. So this becomes 2 times 3 is 6 plus 5 is 1. So that becomes 1 out of 2, right? So I can change it and put 1 out of 2. Okay. So this becomes 1. Then this will multiply an unknown, right? So you can get something like n1, n2. This is representing our eigen vector, okay? Eigenvector. So this should give us 0, 0. So now we come using the row echelon form. Echelon form, what do? You realize that here is 3, 1. Here is 2 over 2. Here is 1 over 2. So you can easily multiply my second row. So my row 2 times 2. Then I'll do what? Subtract it from my row 1. Then I'll put it as row what? Row 2. So see, row 2 is equal to 2 times, let's say row 1 minus what? 2 times. This is a row operation. When I do that, you realize I'll get what? 0, 1. Here becomes 0. Here becomes 0. Because 2 times this becomes 3 when I subtract it be 0. 2 times half becomes 1 when I subtract 0, 0. Multiplying n1, n2, right? And this will give me 0, 0. Is that not it? So once I get this, then you can simply have 3 n1 plus n2 is equal to what? 0. At this point, you make one the subject, but please always make n2 the subject. Please always make the second one the subject. So you have n2 to be equal to negative 3 and 1. Is that not it? Yeah. So when you have such, then what do? You make the n1. You assume a number to it. So mostly we assume 1. Don't use fractions. Okay. We try our best possible to eliminate fractions. The eigenvector that you get is a template, like it's generic. Any other eigenvalue you get using different values of n will give you a linearly dependent vector. It's actually not different from the one we have. It's simply going to be a multiple of that. Okay, so you are going to have the eigenvector to be equal to what? When n is 1, you get 1. Then our n to be what? Negative 3. So this is our eigenvector. 1, negative 2. What's that? Then when our eigenvalue is half, what do we get? You get that my that one will give me negative half, right? Negative half, then 1. Then I also get 3 out of 2. Then remember that we have negative 5 over 2 minus lambda. So my lambda is half. So negative 5 out of 2, negative 5 out of 2 minus half. What do I get? So negative 5 out of 2 minus half, you simply get what? Minus 6 over 2. And that gives me a perfect negative. Right? So I can remove it and put output. This will multiply n1 and I'll get what? Now we are also supposed to perform another row operation here. Just open your eyes. You have negative half 1, 3 out of 2. What is the difference? The difference is obviously this here is 3 times what we have here. So what do? I'll multiply. See, whenever you are performing the row operation, our goal is to achieve an apical triangular matrix as much as possible, right? So here you will find my row 2 will simply be equal to what? 3 times row plus itself. Then you are going to have 3 times this is negative 3 out of 2. When I add, I get 0. I'll put it here is still negative. It's what 3. When I add, I get 0. Here's what 1. Therefore, I still have my n1, my n2. equal to 0, 0. So when I expand, I get negative n1 over 2 plus n2 is equal to 0. Is that not it? And as I said, make n2 the subject. Make n2 the subject. So my n2 is simply equal to my n1 out of 2. At this point, you assume a value for what? N1. So if n1 is 1, I'll have my n2 to be what? Half. Is that not it? But please eliminate fraction as much as possible. So I'll end up getting 1. I'll end up getting, when I multiply here, I'll get what? 2 then 1. Okay, I'll get 2 then 1. So now I have my eigenvectors and my eigenvalues. So what will be my system of equation? What will be my solution? My solution then will be x of t, right, should be equal to, you introduce your variable c1, your constant, e to the power, my first r, because my eigenvalue was what? Negative 3, right? Negative 3. So once I have my negative 3t, I'll attach it to what? Its eigenvector. That is 1 negative. So multiplying 1 negative plus possible, plus my c2, e to the power, that will be what? Half, right? Half. So I have 40 over 2. My eigen vector becomes 2. As simple as that. But we were given initial conditions, please remember. And the initial condition said that our x of 0 is what? Negative 49. So we can apply our initial condition and get rid of what this is. So I'll say that x of 0 is equal to what? Negative 49. Is that not it? Therefore, I'll have my negative, which is equal to c1. When I put 0 here, it becomes 0. So I'll have c1 multiplying 1 negative. Then I have plus c multiplying, because when I put 0, therefore I can find my c1 and c2, the values respectively, by writing my two. That not it. Good. So my c1 will be equal to 22 out of 7. Then my c2 will be equal to negative 3 out of 7. From here it's simple. So it's like you are getting two different. Negative 4 is equal to c1 plus 2c, and 9 is equal to 12, and you get. Once you have your c's, then I think you are done. You are simply going to have x of t is equal to negative 22 over 7, e to the power negative 3t multiplying 1, negative 3, minus 3 out of 7, e to the power t half multiplying 2, 1. As simple. So here, your actual differential equation solution takes the first row. So y of t is simply equal to negative 2 over 7. It's by what? The 1 here. So have e to the power negative. Then minus, here to multiply the 2, minus 6 over 7 power. So this is how you can use terms of equation to solve any differential equation. Interestingly, this is a homogeneous differential equation. We have the non-homogeneous differential equation, which has got similar approaches. Okay. So let's check the second problem. Good. So this is the second problem. It says that solve the differential equation 3xy plus y squared dx plus x squared plus xy dy equals 0. Please, at this point, if you have not subscribed, do well to subscribe, support, and please don't forget to share to your friends if you find this very useful. So we have solved this. Now, whenever you have been given a first order differential equation to solve, what do? You first analyze the differential equation and just see which approach or which method will be very suitable for the differential equation. Which differential equation has got this form? So here, what comes in mind? It should be exact differential equation because it has got the m of x or y, the x plus n of what? X of y is equal to 0. As simple as that. So once you have this in mind, you can easily relate and say that this should be exact. But you know exact differential equation, you need to test. So you do your test for exact before you can go ahead and solve it using exact differential equation. So our test for exact, what do? So let's break it down. Our mx part or the m part is what? 3xy plus y squared. When you say mx, we mean the partial derivative with respect to y part of the implicit here. Then our ny part is n is x squared plus xy. Simple as that. Doing your test, what you do is your x part you differentiate it with respect to y, your y part you differentiate with respect to what? X. Differentiating them with respect to y, that is the m over the y, what am I going to get? I'll get 3x. Here I'll get what? Plus 2y. Is that not it? As simple as that. So 3x plus 2y. Now, the n over the x, what do I get? I get 2x plus, this is what? Xy, right? So when I differentiate it with respect to x, I get y. 3x plus 2y, 2x plus 4. This equation is non-exact. We say it is non-exact. And please, once you identify that it has the exact format, but after testing it is non-exact, it means that you can alter it by finding the appropriate integrating factor, right? Then after you multiply through to convert it to the exact differential equation, or you can proceed. So let's see. So here, what do you do? You first use the format, right? So the equation says 1 over n multiplying your my minus nx, right, should be equal to a function of x, right? And that function of x, the integrating factor is simply equal to e to the power integral of that function of x dx. As simple as that. So in our case, what do we do? I'm going to have 3x plus 2y, which is my my, minus 2x plus y, all over my n. What is my n? My n is s squared plus xy. Okay, so s squared plus xy. So at this point, what do I get? I simplify. 3x minus 2x is x. 2y minus y is what? Is y. So plus y all over x squared plus xy. At this point, I can do some factorization nicely here. X out, x plus y here. That not it. This and this can go, and I'll have 1 over x is equal to f of what? X. Simply. Okay. So now, if you want to find your integrating factor, e of x, what do I get? E to the power integral 1 over x dx. And this gives me e to the power ln x, which is also equal to what? X as that. Once your integrating factor is determined, you multiply through the whole equation by your integrating. My equation, I'll multiply everything. So I have 3xy plus y squared. So 3xy plus y squared dx, right in the back again, plus your s squared plus xy dy. S squared plus xy y is equal to 0. I'll multiply through by x, so I'll end up getting 3s squared y plus xy squared x plus bracket s cubed plus s squared y is equal to 0. Once you've reached this point, the next thing to do is for you to test for exactness, whether what you did is right. Okay. So to test for exactness, I'll differentiate this with respect to y again. That will give me what? 3s squared. Differentiate this with respect to y plus 2 what? X. Is that not it? 2xy. Sorry. When I come here, I'll differentiate this with respect to x. Okay, I'll differentiate it with respect to x, and that will give me 3s squared plus what? 2xy. Powerfully, you can see that now our two sides are equal, so we can go ahead and then solve it as an exact differential equation. For you to solve any exact differential equation, use the easiest approach. Take your m parts and your n parts, integrate separately, then you merge, right? So my m part is 3sy plus y squared. My n part is s squared plus xy. Please integrate each independently. So I have integral of 3xy plus y squared dx, integral of s squared plus xy dy. Then I'll integrate independently. So here, when I integrate this with respect to x, what am I getting? I'll get 3 on 2 s squared y plus xy squared. When I come here, when I integrate this with respect to y, I'm getting s squared y plus, here I'll get x on 2 y squared, right? So here, you after getting these separate integrals, you merge them. Merging means that you combine them, but any overlap, you should just take one. I'll take my first one. 3 out of 2 s squared y plus s squared y. But s squared y appears, so you just take x over 2y squared equal to what? Your c. So this then becomes your what? Your solution to your non-exact differential equation you found above. So this is how you solve it, and I hope you've understood this clearly, right? Make sure you follow and you test for your exactness any points within the solution. We move to the next problem, and please don't forget to subscribe, to be part of the family and you get notified for any future tutorials, right? Okay, so let's solve this problem. He said a person places 20,000 US dollars. Oh, sorry, it's not US dollars, right? It's just dollars. So I wouldn't say US dollars. So a person places in a savings account which pays 5% interest per annum, compounded continuously. Find A, the amount in the account after 3 years, and B, the time required for the amount to double in value, presuming no additional deposits. So a person has gone to place $20,000 in an account, and the account is a savings account, meaning the person will be earning an interest 5% per annum, which is compounded continuously, right? And the first solution is saying that what is the amount in the account after 3 years, then B is the time required for the amount to double in value, provided there is no additional deposits. So how do we solve this problem? You have to first model it as a differential equation. So you can see that this is a growth problem. When I say growth problem, it means that the money is expected to increase. The money is expected to do what? To increase. Is that not it? So I'll have the change of the amount with respect to time should be proportional to what? To the current um to the initial amount, but times 0.05. So it should be proportional to 0.05. That is a 5%. Okay. Therefore, this becomes the n over the t, right, is equal to 0.05n, right? 0.05n. So I think that at this point I could remove the zero point 0.5. So you say that the rate of change of your initial amount with respect to time, the initial amount of money, right? But since it is going to increase by 5%, it means that 0.05 will be introduced here. Okay. Now we have a differential equation. We can solve this differential equation either in a linear or separable. In this format, it appears to be separable, is that not it? But we can say the n over the t minus 0.05 n is equal to 0. This then becomes a linear differential equation, which we can solve it as such, right? So with this in mind, let's use a separable approach and see what you are going to get. If you have a problem like this, what do? You separate variables. So I'll end up bringing my 1 over n, the n, is equal to 0.05 dt, right? Integrating this, I get natural log of n is equal to 0.05 t. That is n, right? So e to the power 0.05 t is equal to what? N. But remember that here you should supposed to bring plus c, okay? After integrating plus c. So here will be plus c, right? So therefore, my n is 0.05 t plus c. What do? Always, whenever you have c as a power, please bring it down. How do you bring it down? You use the indices power, right? So e to the power 0.05 multiplying a t, multiplying e to the power c. But e to the power c is 2c, okay? So our differential equation will become n is equal to c e to the power 0.05 t. So there is the differential equation. Once you are here, you're almost done. Let's go back to the problem. It says that a person places this in a savings account, meaning that at time t equals 0, this was the money in it. So we can use that as our initial condition. So for problems like this, they wouldn't tell you the initial condition. You just have to figure that our n is equal to what? $20,000, right? So I'll bring it here and I'll have $20,000 is equal to c e to the power 0.05 multiplying 0. So 20,000 is equal to c, everything becomes 1, okay? Therefore, my differential equation becomes n is equal to 20,000 e to the power 0.05 t. This is as simple as that. So after doing differential equation, you are expected to be able to solve some interesting problems without you chewing formulas or some kind of thing. we should be able to model the problem. Okay, times e to the power 0.05 times 3. So the answer is 23,236. $23,236. Okay. Then let's go and check the other problem. It says that find the time required for the amount to double in value, assuming there is no additional deposits. For the amount to double in value. Okay. So for the amount to double in value, meaning that our initial amount should be equal to 2 times the current amount, which should be what, 40,000, because there wouldn't be any additional deposits. Therefore, our n is equal to 40,000 at t, which we don't know, and we need to find t, right? So I have 40,000 is equal to 20,000 e to the power 0.05 multiplying t. So you divide, right? So 40,000 over 20,000 is equal to e to the power 0.05 t. This becomes what, 2, right? So we get 2 is equal to e to the power 0.05 t. Then I'll take ln 2 is equal to natural log of e to the power 0.05 t. So ln 2 will be equal to, this gives me 0.05 t. My t is simply equal to ln 2 over 0.05. And what will be the answer? A fraction of 0.05, sorry, ln 2 over 0.05. That is 13.8. So let's say 13.9 years. 13.9 years. As simple as that. So this is a typical application of first order differential equation, and it is a good problem. Let's check out for the next problem. And please, if you haven't still subscribed, do well to subscribe to be part of the mission. Okay, so solve using Laplace transform. This is a non-homogeneous differential equation given these initial conditions. In fact, this is a very packed problem. And mostly, these problems is a single problem which you find it doesn't really come with plenty sub questions. Okay. So to solve this problem, right? Y prime prime minus 6y. So I have y prime prime minus 6y prime plus 15y is equal to 2 sine the expression 3t. So given the initial conditions here, right, y of 0 is -1, then y prime of 0 is -4. So how do we solve this problem? Now, to solve any differential equation, and this is a very likely problem in most of the programs, I think, because you should be able to use Laplace to solve a non-homogeneous. So what do? You take Laplace for each term. So Laplace of y prime prime minus Laplace of what? 6y prime plus 15, sorry, Laplace of 15y is equal to Laplace of what? 2 sine 3t. But before then, let me give you the Laplace transform table because we need that for us to do the transformation. So you should keep these stuffs down. So for the start too. So if you have Laplace of sine 80, okay, equal to what? A over s squared plus a squared is equal to s over s squared plus a squared. If you have e to the power at cosine of the expression b. Then the Laplace is equal to s minus a. I think these two is enough. Come back to that. So let me write it. So Laplace for sine 80, if you have sine 80, is given as what? A over s squared plus a squared. Then cos 80 given as what? S over s squared plus. Note the difference. So for every problem in Laplace, it's likely they are going to give you the Laplace table. Okay. So at this point, you are supposed to find Laplace of everything. But before that, Laplace of anything with a constant, bring the constants out of the Laplace. So I have my Laplace of y prime prime back again, minus 6 Laplace of what? Y prime plus 15 Laplace of what? Y is equal to 2 Laplace of sine 3t. Nicely. So at this point, you have to know the Laplace for y prime prime. Anytime you see y prime prime anywhere, please, the Laplace is fixed. Given us x squared y of x is capital Y of x. Please take note, minus x y of 0 minus y prime of 0. That is for only this. Minus 6 multiplying the expression. The Laplace for y prime is always x capital Y of s minus y of 0 plus 15, and the Laplace of y is capital Y of x plus that is equal to, on the right side, we have 2 multiplying the expression. What's the Laplace of 3t? Remember that I gave you this Laplace of sine. I gave you Laplace of sine what? At is given as what? A over s squared plus a squared. A over s squared plus a squared, right? Therefore, what is my a? My a is a coefficient of t, right? S squared is s squared. I mean, it's a Laplace constant. So what do I get? My a is now 3t, right? So I have my 3 over the expression, my s squared plus what? 9. Take note of that. So I'll simply come and do the expansion here. Then with the expansion, I'm going to have s squared y of s. Please, y of 0 is given in the question as your initial boundary. Okay, y of 0 is -1. Remove it with -1. Y prime of 0 is -4. You remove it with -4. So this becomes what? X times what? -1 minus y prime of 0 is what? -4. Right? Minus 6 multiplying the expression s y of s. So minus y of 0, which is what? Going to be what? Minus minus 1 plus 1 plus 15 y of s is equal to 6 over s squared plus 9. So we keep on simplifying, and this gives us what? S squared y of s plus s plus 4 minus 6 s, right? 6xy s minus 6 plus 15 y of s equal to 6 over s squared plus 9. So at this point, I have s squared y capital of x, s y capital of x, then I have plus 15 y capital of x, then the rest will be what? X plus 4 minus 6. So 4 minus 6 is -2, which is what? S minus 2. And this should be equal to 6 over x squared plus what? 9. At this point, what do? You make y of s the subject. Open bracket, s squared minus 6s plus 15, right? Plus x minus 2 equal to 6 over s squared plus 9. So what do? We just make y, capital Y of s the subject, as simple as that, by switching everything to the right side. To switch, we can switch the s minus 2 first, right? So you have my y of s multiplying s squared minus 6s plus 15 is equal to 6 over s squared plus 9 minus s plus 2, right? So what do? I cross multiply. So solving this part alone, I'm going to get something like 6 minus s cubed, right? 6 minus s cubed minus 9s plus 2s squared plus 18, right? So let's do it here. So I have y of s multiplying s squared minus 6s plus 15 is equal to negative s cubed minus 9s plus 2s squared plus 18. Everything over s squared plus 9, right? So let me see. I think I omitted the plus 6. Okay, so the 18 plus the 6 here, that was plus 6 here. 18 plus it should be 24, not 18. So plus 24. So my capital Y of S is equal to negative S cubed minus 9S plus 2S squared plus 24 all over the expression S squared plus 9, one bracket, and the coefficient here, S squared minus 6S plus 50. So at this point, it's a very heavy point in Laplace. We are done. Right now we have our solution, but the solution is in not it's not in Y, it's in Laplace. This is where we have to do what we call inverse Laplace to get back our solution. But how do we do that? We need to first decompose our function here, which is very complicated, into simpler form, and find the inverse Laplace of item, and that is all. Though it is a heavy work. So how do we do that? So the expression here, remember that we have two quadratic, is that not it? So expressing this as partial fraction, I'll have y of x is equal to as plus b. Please, here we don't use x, we use s, okay? Over the expression s squared plus 9 plus here, please, this one I cannot break to linear. So over what? Cs plus d, s squared minus 6s plus 15. At this point, you are not done. You are supposed to still simplify further, okay? So now that I have this should be equal to negative s cubed plus 2s squared minus 9s plus 24 over s squared plus 9 s squared minus 6s plus 15. So here is where the real work comes in. So I have as plus b multiplying s squared minus 6s plus 15 plus multiplying s squared plus 9. And this should be equal to negative s cubed plus 2s squared sin as. Okay. Then I'll still come back again. Plus bs squared minus 6bs plus 15b. Then I come here. So 15b. When I come to this, I have plus cs cubed plus 9cs plus ds squared 9d. So now with this, you group like terms. So all cube will go on one side. I have as cubed, cs cubed, right? So as cubed plus cs cubed on one side. Now let's as squared plus bs squared plus ds squared. Don't you have cs squared? No. Yes. So plus ds squared, right? Then this one too in another bracket. That was minus. So now then I go to my s, right? So the s2 I have plus 15s, 15 as minus 6bs. Then I have plus 9s ds. Sorry. Then I think that is all. Then finally the standing terms I have 15b 15b then what? Plus 9d. 15b plus 9d. Okay. So now we go to this term, the negative s cubed minus 2s squared. Then we do like terms, right? So here I have negative s cubed to be equal to as cubed plus cs cubed, right? My s cubed goes away and you realize I have a plus c is equal to what? Negative 1. Is that not it? Yeah. You circle it. When I come to my b, I have negative 6 as squared plus bs squared plus ds squared. What's the s squared? 2s squared, right? All my s squares to go away. I'll get negative 6a plus b plus d is equal to 2. Another equation conceived. I come again. all my s should come. So my s, I have 15as minus 6bs plus 9cs. And what is my s? Negative 9c, right? Negative 9s, sorry. All s should go away. I have 15a minus 6b plus 9c is equal to negative 9. Then finally we have, sorry, the straight terms, which is the last part. I have 15b plus 9d. 15b plus 9d should be equal to what? The standing term, and the standing term is equal to what? 24, right? 24. This gives us our fourth equation. With this fourth equation, we should be able to find the respective values for a, b, c, and d. How do we do that? How do we do that? So this one is just, the calculator doesn't solve for. We have the one that solve for. Let me see if I can break something down. So here, if I'm to make c the subject, I can come and put a here. Then what else? A, B, D. Okay, we have BD, we have BD. That would be very, very easy, right? What do we do? We simply make let's say BD, 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 and BD. Can't I divide here by 3? Dividing this equation 4 by 3, I'm going to get 5b plus 3d is equal to 8. Right? Therefore, I can have my equation. Well, I think that you can take time, then solve for each of the variables. But for now, let me give you the respective. So A is equal to, this one is just calculator where you just take your time, you go through, you should be able to do it. So A is equal to 1 out of 10. B is equal to 1 out of 10. Interesting. C is equal to negative 11 out of 10. So these are the respective coefficients you should be expecting, right? So once you have this, our equation comes. My y of s becomes my a, right? 1 out of 10. So we have, let me write my equations back again. As plus b over s squared plus 9 plus cs plus d over s squared minus 6x plus 15. So introducing the variables, I have 1 out of 10 s plus 1 out of 10 over s squared plus 9 plus my c negative 11 out of 10 s plus 5 out of 2 over s squared minus 6s plus 15. Once I have this done, what do? I can factorize out of 10 here. So 1 out of 10 out, s plus 1 all over s squared plus 9, right? Plus, here I can factorize 1 out of 10. But when I factorize 1 out of 10, remember that I'll have to multiply the top by what? By 5, down by 5 to get also here. So this is what I'm doing. Times 5 over 5, right? I haven't done anything. I haven't changed anything. Remember, this is 1. This gives me 25 over 10. That means I can factorize 1 out of 10 out, right? So I have another 1 out of 10 out. And I'll have negative 11s plus 25 over the expression s squared minus 6s plus 15, right? Nicely done. Then I can then say that 1 out of 10 generally out, s plus 1, s squared plus 9 plus negative 11s plus 25 over s squared minus 6s plus 15. So with this, we need to find the inverse Laplace of this to get the actual. Let me introduce the inverse Laplace here. I have, let me introduce them here. Remember that if I have e to the power at cos bt is the same as s minus a over s minus a all squared plus b squared. E to the power at sine bt is the same as b over x minus a all squared plus b squared. Okay, then if you have sine at is the same as a over s squared plus a squared, and if you have cos at is the same as s over s squared plus a squared. Using this idea, how can we modify what you have here so that it's going to look like exactly what we have here? How do we modify that? So to modify this, you will realize that we are supposed, here it's not linear, it's very strategic. Okay, it's very strategic. So to do that, I'm going to have my s minus a here. Yeah, please wait. So I have my x minus a here, right? My x minus a here. And I'm supposed to get x minus a squared plus b squared to get this. Then please look at it well. Now look, I have x plus 1, s squared plus, I mean, I can't relate anything here. So I need to massage this. And in the massaging, it's very tricky, very tricky. Okay. So what you can do is, because we have b here, right? Okay, because we have s over s squared plus 9 a squared here, I can separate the x here. So my first manipulation is 1 out of 10 outside. I'll have s over s squared plus 9 separately, plus 1 over s squared plus 9 separately, right? That is the first step. Then plus, when I come to this side, what more can I do? Let me hold on with that. So at this point, you can see that I have s over s squared plus 9, and it's exactly as what I have here. Is that not it? S over s squared plus 9 a squared, meaning it will become what? Cos 3t. That is perfectly done. When I come to my 1 over s squared plus 9, that is representing the a over s squared plus a squared, meaning that the a I have here as the numerator should be exactly the what? The square of whatever I have here. But here I have 9 and I have 1, meaning if I want to maintain this 9, here must be what? 3. Is that not it? Then I can say that a squared like that, right? So what do? I can introduce 3, but you can't bring 3 just like that. You have to make it 3 over 3. That is the idea. Once you make it 3 over 3, you have not done anything. Like, you have not touched anything here. It's just 1, right? So multiplying this by 3 over 3 means that it's just 1, right? So what do we do with the 3 over 3? Then we can say that once here is 3, we can have 1 over 3 stepping out, right? So this becomes 1 out of 3, multiplying the expression, then the top one becomes 3, as simple as that. So now we have, what do we have here? We have 3 over s squared plus 9, then 1 over 3. Then you can clearly see that I have my 3 and I have my 3 squared here. So my 9 becomes what? 3 squared. Then another inverse sorted, as simple as that. We are done with this side. So then we can say that this one is what? My s over s squared plus a squared. It becomes what? Cos 3t, because it's cos 80, plus this is 1 out of 3. 3 over this, you can see that sine 3t. We are not like that. 1 over 10. Now let's go to the second part, this side. I have negative 11s plus 2 25 over s squared minus 6s plus 15. There is no way I can see. But what I'm seeing here is I have my s minus a all squared plus b squared. Is that not it? We do what we call completion of squares. You've done this in high school. So for completion of squares, what we are trying to do is you take the coefficient of our s here, you divide it by 2, you add and subtract. Now, let's do that one separately. So I have my s squared minus 6s plus 5. Take is what? Negative 6. Divided by 2 is what? Negative 3. I'll add and what? Subtract, right? I'll square it too. I'll add and subtract the square of it. So I have s squared plus negative 3 squared minus negative 3 what? Squared. plus what? 5. As simple as that. This gives me x minus 3 all squared. This becomes negative 9 plus 5. And that gives me what? Negative what? 4. Let me see. Sorry. It's actually plus 15, not plus 5. I think I omitted it alongside. It's 15, okay? So 9 plus 15 is what? 6, okay? So therefore, this expression here, I'll clear it and it will become what? X minus 3 all squared. Then I'll have what? Plus 6. Like that. Then you can see we are approaching this, right? Now I have my x minus a squared. I have this. Then I have b squared. So what am I seeing? I need to still go ahead and simplify. Let's see something tricky here. Think I've reached completion. So at this point, let's see the manipulation very well. So the manipulation is that with these two that I have, one is b and one is s minus a. I can keep my s here and I can keep my b by separating the two again. So I can separate this again, right? So let's separate it. I think my workbook here is full. So separating, I'm going to have negative 11. I have negative 11 s over s minus 3 all squared plus 6 plus 25 over x minus 3 all squared plus 6. Right. Now, with the 25, then the plus 6 here. Here, I have minus a all squared, then the b. Remember, the b squared and the b should be the same. So, meaning my 25 here and my 6 here, it should just be 1 and a square. As simple as that. But let's handle the 11s. So, with the 11s, this is what I'll do. My s here, I can make minus 3 plus 3. If I don't know if it makes sense. I'm just trying to make it s minus a. So minus 3 plus 3, I have not done anything to it. I just introduced a 0. But when I expand, you realize I'll get negative 11 s. But how do we get 6 here to be equal to b squared, right? So my 6 here now is becoming b squared. But here, I'm supposed to get rid of this 33. Root 60 minus 8 over root 6 e to the power t sine root 60. This is it. So thank you very much for being with me in this tutorial, and all the best in your exams. Please don't forget to subscribe to be part of the family. Share to your friends as well.